Okay, so we have the series n equals 0 to infinity, -1 to the n, x raised to the 2n, all over 2n factorial. So our center here, we don't have x minus anything, so it's really an x minus 0. So our center is at x equals 0, and then our next step is to find our radius. So we'll start by setting up our ratio test. L is equal to the limit as n goes to infinity, the absolute value. So we'll do our n plus 1 term. We have -1 to the n plus 1. We have x raised to the 2, and then that's times n plus 1 in parentheses. And that'll be divided by 2, and then again, that's n plus 1 in parentheses, factorial. And then we'll divide all of that by the nth term. So I have -1 to the n, I have x to the 2n, and then I have a 2n in parentheses factorial that pops up in the numerator. All right, so these -1 to the n and the n plus 1 are going to go away because I have an absolute value here. And this 2n plus 1 is really a 2n plus 2 when you distribute the 2. So these 2n's cancel, and I'm left with an x squared. And since there are no longer any n's involved in the x, I can pull that out in front of the limit. So the absolute value of x squared out in front, I have the limit as n goes to infinity. And then this 2 times the quantity n plus 1 is going to end up being a 2n plus 2 factorial. And a 2n factorial over a 2n plus 2 factorial leaves me with 1 over 2n plus 2, 2n plus 1. And as n goes to infinity, this whole thing is going to 0. Okay, and then remember that our criteria for the ratio test for it to converge is that our limit needs to be less than 1. Okay, well, if this part here is going to be 0, it doesn't matter what x squared is because our limit will always be less than 0. So any value of x is going to work here because this is going to be 0. So 0 times anything is going to give us 0, which will always be less than 1. Okay? So that means our radius is infinite because our interval is going to be all real numbers. So you can write your interval as that r with the double bar on the back side of the r, or you can write it as -infinity to positive infinity, or you could write -infinity less than x less than positive infinity. But any value of x will work, and so that means our radius is infinity here. Okay, so that would be an example of any real number we use will work. Let's take a look at number 4. So I have this series, n equals 1 to infinity, of n minus 1 factorial times x to the n. So again, let's start by looking at our center. So I just have x raised to the n, so it's not x minus a number. So my center is x equals 0. If it had said x minus 5, then my center would be x equals 5 or something like that. This will just be x equals 0. And my next step is to find my radius, and I'll do that by applying the ratio test. So L is equal to the limit as n goes to infinity. We'll do the absolute value. Now I have n minus 1 factorial. So if I add 1 to this to do the n plus 1 term, I have n minus 1 plus 1, which just gives me an n factorial. And then I have an x to the n plus 1. I'll divide that by the a sub n term. So that gives me an n minus 1 factorial and an x to the n. Okay, and simplify this by pulling out the absolute value of x in front of the limit. And I'm left with the limit as n goes to infinity. And n factorial divided by n minus 1 factorial leaves me with an n here. So this limit is going to infinity. So kind of the exact opposite of the previous problem we just looked at. So the only value of x that will give us a limit less than 1 is when x equals 0. Okay, so that's going to be at the center. Okay, so if your limit goes to infinity, the only value that your power series will converge for is the value at the center. So if I plug x equals 0 in, now I have 0 times whatever's going on here. And so this is the only way I can keep this to be, to get this to converge. Okay, so my radius is going to be 0. And the way that I write this interval, you may not have seen this notation before, but I use these curly brackets and I put the number that I want to use in there. So in this case, my center is 0, so I would put a 0 in there. Okay, so this is the number that it's going to converge for. So if my center had been x equals 5, then I would put a 5 in here. So these are kind of the two contrasting examples. Normally you're going to get a finite number with this limit and go through testing the endpoints. But these would be your two other possibilities. Either it converges for only the center of your interval or it converges for all real numbers.